All right, everyone. So today we're going to talk about our functions still, but this time we're going to talk about discrete versus continuous functions because we have two different kinds of functions to talk about. So discrete ones are going to look like this in our graph. So it's just going to be individual points here. They're not like a line. They're just little points at each piece of data. So these are going to be something you can count. All right, and then we have continuous functions. Those will be a line. Each time you graph a continuous function, it will be some sort of line that is doesn't have any holes in it or anything like that. Okay, so let's get a little bit deeper in there and go to discrete first. So, discrete functions. Functions are discrete if the values are distinct, meaning different. They are separate, meaning they don't touch, and can be counted, like individually. So they are possible to count. It's not something that's like, like we said before, like a line. It's individual little pieces. So they are all different, they are separate from each other, and they can be counted. Okay. So finding the domain and range. So we talked about this in class, but if you missed it, the domain is basically every input and X value. Our range is all of our outputs and Y values that we can have in our function. So both the domain and range will be a list of values between curly brackets. And by curly brackets, I mean these symbols here. Those are what curly brackets look like, and you'll see them a little bit later too. Okay, so for our domain and range, those are going to be kind of important, and they will definitely come back even after this unit. So I kind of wanted to get this down now just so we have that in our brains for later. So I'm going to use two different colored highlighters for these just so that we can clearly see the difference between the two. I'll use blue for domain and purple for range. So our domain, like we said before, the domain is going to be all of our inputs or our X values. So inputs on our table here are going to be all of these guys. Just like it said above, it's going to be a list between curly brackets. So that's my first curly. And then we got 1, 2, 3, and 4. And that's my domain. It's just a list of all of the possible values that our domain can have. So let's try the range. The range is going to be all of our Y values or outputs. So that's these guys here. We're going to use our curly brackets. That's going to be 5, 10, 15, and 20. And that's going to be about it for our domain and range. All right, so let's take a look at what it looks like on a map. So once again, I'm going to use the same colors. Domain is blue, range is purple. Our domain is going to be all of our inputs. So everything that got put into our function is right here. Once again, we're going to use our curly brackets. I got a -3, a 1, a 4, and a 6. All right. Our range is going to be all of our outputs, so everything that comes out is going to be over here. We got curly brackets. I got a 9.5, -0.5, a -8, and a -13 with curly brackets at the end. You're basically just copying all of the ones that it tells you are in your domain and in your range. You just need to know where to look. Okay, so once again, in class, this was something we talked about a little bit more, but these are going to be all points. So remember, points are going to have an X and a Y. Each one is an X and a Y. So for our domain, we said that was all of our X's. So we want all of the X's. Once again, we're going to start with curly brackets. I got a -2, 0, 2, and 3. The other way you could see this is by putting it in a table. Whatever way makes it easier for you to see. Whoopsies. Whichever way makes it easier for you to see what's going on is fine. Whatever works for you, and that's totally good. Because it's going to be the same thing no matter what. This is still going to be your domain. And then, oopsies. This is going to be your range. All your Y's. So this side of our table. Like I said, you don't have to make the table. If you could just clearly see which ones are your X's and which ones are your Y's, that's fine. You could just do it from sight. I'm just offering you another way to look at it. Okay. And then we have this guy. So, domain is going to be blue. So I'm going to highlight where it would be. Remember, the domain is going to be all of your X values. Since we don't really have any numbers here, we're going to highlight our X axis and see where each dot falls on that axis. So the first one is going to go right here to -2. So first in line is going to be -2. This one is at 0, so that's 0. This one's at 2. This one's at 4. And this one's at 6. Neat. Okay, so now we need our range. We said the range is going to be purple. So we are going to need our Y-axis for that one. You don't need to erase anything. I'm just doing that so we can see a little bit clearer what's going on. So looking at my Y-axis now, I'm going to need where those values are. So I'm going to look at the first one, that's at 2. The next one is at 3. We got 4, 5, and 6. And that's going to be our range. This one's going to be a little bit trickier when we go to our continuous functions, but that is there for you in case you need it. Okay. Let's go on to those continuous functions. Continuous. Continuous functions can have any value. They could be literally any number you could think of. Including decimals, like complicated decimals, like 1.7894, some that goes on for a long time, and fractions. As long as it's a real number, your continuous function can be on it. So these domains and ranges are going to look a little bit different than our discrete ones. So the domain and range will be represented using inequalities. Now, inequalities are something that we used before in topic 1, and they looked like this. So this one was less than, we had greater than, less than, or equal to, and greater than or equal to. Remember, you could tell which one it is by looking at the end of your symbol here. It starts with a smaller one, so that's going to be less. This one starts with the bigger end, so it's going to be greater. Okay, so like I said, we're going to use these inequalities to do our domain and range. I'll still use the same colors here just so that we don't get lost. But our domain and range is going to look a little bit different. Recall, your domain is going to be all of your X values, so I'm going to start with an X here. Now, I'm going to look at the values that are on this line. So I see that this function has a starting point right here, and that's at -6. So I know that our domain is going to start at -6. Now, since we're looking at our X-axis, we're going to see how far this goes from the left to the right. Now, since we have an arrow over here, that's going to tell me that this goes on forever in that direction. So since this is getting bigger, it's getting greater. So our function will cover every number that is greater than or equal to -6. Now I have that or equal to line here because this is a filled in dot. And that was something that we talked about before as well. So our domain is going to cover every x value from -6 on to infinity. It'll just go on from there. So x is any number greater than or equal to -6. Okay, so let's think about our y values. Let's think about our range. That's going to be this y-axis here. So once again, we're going to look at where it starts, but for these, we're going to go from the bottom to the top. We're going to go from the bottom up, and we're going to look at our y-axis. So I see it starts right here. Where that is on the y-axis is going to be at 0. So it's going to be 0 over here, and we're going to have a y to start with because this is all of our y values. Okay, so we're going to go from the bottom to the top. Now, once again, this has an arrow at the top. It doesn't stop. So it just is going to keep getting bigger and bigger and bigger and taller from where we are. So since it's getting bigger, once again, we're going to have that or greater than or equal to. So our range is going to go from 0, where it starts on the y-axis, that's right here, and then it's going to go up from there. So we have y is greater than or equal to 0. Okay, domain and range could be a little bit tricky, so let's take a look at another one. All right, this looks a little different. This one has 2 endpoints, and we'll see what that does in a second. I know my domain is going to be my y-axis, and I'm going to just put down it's going to be my x-axis, and I'm putting down an x so that we could see that. All right, remember, for your axes here, you're going to want to go from right to left. So you're going to go from one side down to the other side. So I'm going to start here. That value is going to be at -3. And then it ends over here at +2. So that's going to be a 2 right there. All right, to show that I'm going from smallest to biggest, I'm going to use our less than inequalities. And since this dot is filled in at -3, I'm going to use our or equal to line. Okay, let's take a look at the range. That's going to be our y values. So I'm going to start with a y over here. Okay, so I'm going to go from the bottom to the top up here. I'm going to go from down, up. That's the range that I'm looking at right now. So that is going to start at the very bottom of our function where these 2 dots are. That's at -2. So -2. And then we're going to go to the top of it. That goes all the way up here. That's the top. That's at +3. Once again, I'm going to use those less than symbols because we're going from the smallest to biggest. And I think we're going to be good. Oh, no, I still need my or equal to lines there. Now we're good. So this is telling us that it can go from -3 to +2 long ways. And then from bottom to top, it'll go from -2 to +3. Okay, let's see another one. All right, a little bit curvier, that's okay. I'm gonna look at my domain first. So going from left to the right here. Okay, I'm starting at my start point. That's gonna be right here. That's at -2 on my x-axis. So I'm going to have an x, and I'm going to start with -2. Then I'm going to keep going until I hit the end. It looks like the end point is right at 4, but the function goes past that. It still has another bit here right at the end. So that is where our domain is going to stop, is right at the end of the function. It doesn't matter that there's a point right here. We want the very end of it right here. Okay, so that's at +5, so I have a +5 here. Once again, I'm going to use my less thans to show that it's going from smallest to biggest. And then I see that this point is going to be covered. Oops. That this point is going to be covered by our number. So I'm going to put an or equal to line beneath it. Okay. Range is coming next. Right here. Our range is going to be our purple line. And that's going to show us our range. We're going to go from from bottom to top again. So wherever our endpoints are, that's going to be right here. That's at 0. I need a Y. And then for the next one, that's going to be the top, and that's at 6. Once again, our 4 is going to be included in there. Sorry, our 0, not our 4. 0 is going to have a line underneath it. So that is our range for this function. Okay, last one we got here. Let's take a look at the domain first. Ooh, this looks different. This one has arrows on the ends. So remember, those arrows mean that they go on forever. They're going to go on for infinity going this way and infinity going the other way. So if that happens, there's no stopping point at all. It's just going to go on forever. Because of that, we're going to say that our domain is all real numbers. And that's going to be the same thing for the range because it's also getting bigger. It's going to go up and up and up and down and down and down. So that's going to cover every single possible number that will come up. So both of these answers will be all real numbers. And just a word of warning or caution or advice, if you ever see 2 arrows, you're going to know that at least one of your answers will be all real numbers. If not both, then at least one if you got 2 arrows going on. All right, so that's going to do it for discrete and continuous functions. Hope y'all have a good day. I'll see you later. Bye.